Do you have any doubt from previous class?
No.
Okay. So starting a new topic from ionic equilibrium, which is buffer solution. What is buffer solution? Basically, a solution which resists the change in its pH when you dilute it with a small quantity of solvent, or when you dissolve a small quantity of acid or base. If the solution will resist change in its pH, that solution is called buffer solution. You don't have to add a lot of acid or a lot of base, then definitely it will change. It is said that a small amount of acid or base, or you can dilute it with a small quantity of solvent. Got it?
Yes.
Okay, write with me. The solution which resist the change in pH on dilution or with addition of a small amount of acid or base is called buffer solution. Is called buffer solution. Now see here, there are two types of buffer solution. Types of buffer solution. Two types of buffer solution. One is acidic buffer and the second is basic buffer. Acidic buffer and the second is basic buffer. Just write it and let me know if you are finished with this.
Done.
Very good. Types of buffer solution, two types, acidic buffer and basic buffer. Now, going to explain what is acidic buffer. First write with me and then I will explain it. What is acidic buffer? It will have two definitions. First definition is, it is the mixture of weak acid with, it is the mixture of weak acid and its conjugate base. And its conjugate base. Can you write conjugate base of an acid if I'm telling you that HCl? Can you write conjugate base of this? Yes or no?
No.
No?
No.
We have studied in Bronsted-Lowry concept that this is HX and this is H2O. If it will react with each other, it will give Cl minus and H3O positive. Yes or no?
Yes.
Now, this HX is donating H plus. That means acid. Yes or no?
Yes.
And it is converted into X minus. That means conjugate base. The substance which donates H plus is called acid, and formation of the compound or molecule or anything after donating H plus is called conjugate base. And you can see H plus donor, H plus acceptor is base, and after accepting, the substance is formed is conjugate acid. So if I'm going to ask you that what is the conjugate base of this, so you just have to remove H plus, it will be converted into Cl minus, and this Cl minus is conjugate base.
Okay.
Or if I will ask what is the conjugate acid of this conjugate base, what is the conjugate, you just have to add H plus. If I'm going to ask you what is the conjugate acid of this base, so you just have to add H plus, so it will be converted into H3O positive. The substance which gets H plus is called conjugate acid, and the substance which removed H plus is called conjugate base. Is that clear?
Yes.
So if I'm going to ask you about HSO4 minus, what is the conjugate base? For conjugate base, you have to remove H plus, so it will be converted into SO4 minus 2.
Yes.
And if I am asking what is conjugate acid, you just have to add H plus, so it will be converted into H2SO4.
Yes.
Okay, just write it. Can I erase this all?
Yes.
Okay. So the first definition is there must be a weak acid and conjugate base of that weak acid. I have uh, written it all in a strong electrolyte and a weak electrolyte, a strong acid and a strong base, and you can keep that in mind, that which is a strong acid and which is a strong base. Now see, we have CH3COOH. What is this, acid or base?
Acid.
Acid. Is it a strong or weak? A strong or weak?
Strong.
Not a strong. This is wrong answer. You have to study the previous lecture, because I wrote it in weak acid, a weak electrolyte, that all organic acids are weak acid. You have to remember the list of a strong acid, that is Hi, HCl, HBr, H2SO4, HNO3, HClO4. These all are a strong acid. Is that clear?
Yes.
Now see, this is organic. Ethanoic acid, it is organic compound and it is acid. So it is basically what? It is weak
Weak
acid.
acid.
Okay. So if you are going to mix this weak acid with conjugate base of this weak acid, can you write the conjugate base of this? Yes or no?
CH3COO minus.
CH3COO minus. So this mixture is acidic buffer or buffer solution. Is that clear?
Yes.
And the second definition comes, it is the mixture of weak acid and its salt with a strong base. You know that how salt forms acid plus base, right? Acid plus base will give salt plus water. Yes or no?
Yes.
Now see, what does this definition say? It is the mixture of weak acid. Weak acid, just take a weak acid, that is CH3COOH, and a salt, and its salt with a strong base. That means there will be a salt, formation of salt, and that salt is made from this acid, this weak acid, and a strong base. NaOH is a strong base. All the hydroxide of first group element is a strong base. I told you in the previous class.
Yes.
Now see, from here you know that this is acid, this is base, so H2O will come out. This will be H2O. You can see this is positive, this is negative, this is positive, this is negative. So it will come here and it will be, this is basically salt. And this salt and this CH3COOH, this mixture is acidic buffer. So always remember what is acidic buffer. In both cases, we have to take weak acid. In the first case, you have to take weak acid with its conjugate base. And in the second case, weak acid with its salt with a strong base. So both are basically acidic buffer. Is that clear?
Yes.
Okay, just write it.
Done.
Very good. So we have to keep both in mind. That is, we are going to take example. Just let me know it is right or wrong. CH3COOH. Is it weak acid? Yes or no?
Yes.
And if we are going to take its conjugate base, it will be like this. Or either we can take its salt with a strong base. So either you can mix this, it will be acidic buffer. Either you can mix this, it will be acidic buffer. This is the first example. Second example, I'm just taking a weak acid. You have to make its conjugate base and its salt with a strong base. Can you make it? Can you prepare it?
Conjugate base will be Cn minus.
Cn minus. Very good. And what will be the salt of its with with a strong base? You just have to, this is what this is basically, this is a strong weak acid. And what is the whatever you want to take a strong base, NaOH or KOH, then what will happen? H2O will move out. Or you can see that like this, Cn is basically negative, hydrogen is positive, Na is positive, OH is negative. So just it will be NaCN. Yes or no?
Yes.
So in the next three examples, you have to solve it on your own. I'm going to take HCOOH, and you have to make its conjugate base as well as salt with a strong base. H2CO3. Fifth is H3PO4. Sixth is H3PO3. So please solve it and let me know.
The conjugate base for third one will be COO minus.
Yes, yes, exactly. It will be not CO minus. I haven't written it correctly. Now let me know. HCOOH.
COOH minus.
COOH minus, not CO, HCOO minus. Okay.
And for the next one, it's
Yes.
HCO3 minus.
HCO3 minus.
Yes.
Like
for the
this.
fourth one.
No, I'm not talking about it. what will be the another here? What will be the basically salt with its salt?
HCOONA.
Very good. HCOONA. Okay. What about H2CO3?
HCO3 minus.
Very good. HCO3 minus. What about the salt?
HCO3Na.
HCO3Na, or we can write NaHCO3. That will sodium hydrogen carbonate. Right?
Yes.
Okay. What about this? This is basically H2PO4 minus, and we can write NaH2PO4.
Yes.
In the same way, we can write H2PO3 minus, and we can also write NaH2PO3.
Yes.
Very good. Just write it and let me know. Can I change the slide?
Yes.
Okay. Okay. Which of the following are acidic buffer? ये आपके पास NaHCO3 plus Na2CO3. B is HCl plus NaCl. CH3COOH plus CH3COO NH4. D is HCN plus AgCN. NaH2PO, NaH2PO3 plus Na2.
First one is acidic buffer. Second one is not acidic buffer.
Very good. First one is acidic buffer. Second one,
Is not.
not, because this is a strong acid, so it won't be acidic buffer. What about the third one? This is a strong base. Sorry, this is weak acid, right?
Yes.
Weak acid. What about this? Just think about it. This is salt, but what type of salt? This is basically salt of CH3COOH plus NH4OH. That's why H2O is out, and here you can see CH3, a salt COONH4 is formed. Now you can see that this is a weak base, but according to the definition, we need weak acid and its salt with a strong base. Okay.
Okay.
What is the list of a strong base? That is NaOH, KOH, CSOH, RBOH, and BaOH whole twice. These all are a strong base, and apart from this, all are weak base. Is that clear?
Yes.
So this is also not correct. What about HCN and HgCN? This is weak acid, no doubt, but this is salt, and salt with, you can see, AgOH plus, this is basically HCN. So basically this is weak base. That's why it's not. So this is basically salt with weak base. Are you getting my point?
Yes.
Now see this. This is basically NaH2PO3. That means removing one decimal, it will be converted into. Can you solve it? Whether it is weak or strong. Can you tell me?
Um,
Just see. I'm sliding it up. NaH2PO3 is basically, I can convert it into H2PO3 negative, and you can also convert it into HPO3 minus 2. Just see, can I say this? It is weak acid because it will be converted into this. That means this will be giving H plus. That's why it is weak acid. Yes or no?
yes.
First of all, it was H3PO3. Then I just remove one of the hydrogen and put it NaH2PO3. It can also remove one of its hydrogen again. So it will be like this. And this weak acid is reacting with NaOH. That means you can see H2O, one of the hydrogen will live with this, and this Na and Na will be Na2, and then HPO3. This will be salt with a strong base. So it forms acidic buffer. Okay.
Okay.
Can I change the slide?
Yes.
Okay, changing the slide. Now come to the point, basic buffer. Basic buffer solution. I'm going to write the definition. It is just same as that of acidic. In acidic, we take weak acid, and in base, we take weak base. So there will be two definitions of this as well. It is the mixture of weak base and its conjugate acid And what is conjugate acid? You just have to add H plus. Are you getting my point?
Yes.
Now the another definition is, it is the mixture of weak acid and its salt with a strong base. Taking some examples, NH4OH is basically, NH4OH is weak base. And if you are going to make it conjugate acid, just remove OH minus, it will be NH4 positive. Yes or no?
Yes.
Proton. Or if you want to make a salt with a strong acid, you just have to react this weak base with a strong acid. You know that this is negative, this is positive, this is negative, this is positive, negative. So the salt will form NH4Cl. And if you are going for NH3 is weak base. This is weak base. So what will be the conjugate acid of its? It will gain H plus, so it will be converted into NH4 positive. Okay, and what it's salt with a strong acid, it will be same. Okay, so I'm going to write a strong acids list. That will be HCl. Again, I'm going to write HBr. HCl, HBr, HI, H2SO4. I already wrote it. HNO3, HClO4. It's all a strong acid. Treats as a strong acid.
Done.
Very good. Now, can you tell me CH3COONA plus CH3COOH, is it buffer solution or not? HNO3 plus CH3COONA, is it buffer or not? Is
Yes.
it buffer solution or not? The first one.
Yes.
What you just said,
It is buffer solution.
it is already buffer solution. And which buffer solution, acidic or basic?
Acidic.
Acidic, because weak acid with
Strong base.
salt, with its salt with a strong base. Okay.
Yes.
एक बार, am I audible?
Yes.
Just see now, it is already buffer. The second question is, can it be buffer solution or not? Can it be buffer solution or not?
No.
No, because this is, you think, you thought that this is a strong acid, and
Yes.
basically this is salt with weak acid and a strong base, right?
Yes.
Now just think that if these mixtures are together, it will react with each other like this. Positive will go to negative, negative will go to positive, and formation of a new compound, that is CH3COOH plus NaNO3 will form. Yes or no? I'm not telling you that this will be buffer solution, but there will be some condition that it can be buffer solution. Okay, just suppose this in the reaction is completely used in this reaction, that means this is limiting reagent, it will be over after reacting with this. In the solution, if this will limiting reagent, do you know what is limiting reagent?
Yes.
This is limiting reagent, that means it will be completely used, it won't be left in the reaction. So, and definitely this will be in excess. So what will be left in the solution? This is weak acid, right?
Yes.
And this is salt with this weak acid and a strong base.
Yes.
So it can be buffer, it can be buffer
Yes.
solution. Condition is HNO3 should be limiting reagent, only then it will be buffer. Okay. Okay.
Yes.
Okay, just write it and let me know.
Done.
Conclusion, write a conclusion with me. In acid base reaction, if a strong acid or a strong base are limiting reagent, then it must be buffer solution. Okay, some more examples you can see. 10 mole of CH3COOH plus 5 mole of NaOH. You can see CH3COOH react with NaOH. It will form, you can see negative, positive, positive, negative, CH3COONA, salt, and H2O. Now just think that this is a balanced reaction. 1 mole of this reacted with 1 mole of this to form 1 mole of this and 1 mole of this. Now it is given that this is 10 mole, this is 5 mole. That means this is basically limiting reagent. What will be left in the solution? This, and the water. So this will form
Buffer solution.
buffer solution. Are you done with this?
Done.
Okay. Next, you have to check it. 5 mole of NH4OH plus 2 mole of HCl. Is it buffer or not?
Yes.
It is buffer solution, right?
HCl will be the limiting reagent.
Yes. And what will be the product? Basically, there will be a salt, and here it will be H2O. This is Lr. So this is weak base and salt with a strong acid. So basically, it is basic buffer. Yes.
Yes.
Okay. So moving to the next topic, which is basically Postwar Dilution Law. Postwar Dilution Law. I'll write a topic and then let me know, then I will explain. First, write with it only applicable for weak electrolyte. Okay, are you done with the topic?
Yes.
Now see, a weak electrolyte is here, which is acid. It will dissociate into ions H plus and A minus. And you know that if it is weak electrolyte, it won't be 100% dissociated, right?
Yes.
If we have a concentration C initially, before dissociation, the concentration of H plus will be 0 and concentration of A minus will be 0 as well. Now, if X is dissociated from C, here X and X will be formed, yes or no?
Yes.
Now see, alpha, that is degree of dissociation, has a formula, that is dissociated moles upon total initial moles. Dissociated moles upon initial moles. So the dissociated moles is equal to C alpha is the value. The value of X is C alpha. Okay, so I'm going to replace it by C alpha and here form C alpha and again C alpha. Is that clear?
Yes.
Now going to write Kc for this reaction. Kc for this reaction will be equal to H plus into A minus and upon HA. In the same way, I'm going to write this Kc will be equal to H plus. The concentration of H plus, you can easily see what is the concentration of H plus, that is C alpha into C alpha, and the concentration of HA, that is C minus C alpha. I'm going to just solve it. Ca square into alpha square upon, I'm going to take C as common, so 1 minus alpha will be left and 1 of the C will be cancelled. So this is basically Kc, that is left with C alpha square upon 1 minus alpha. Are you agree with this?
Yes.
Now this Kc is basically Ka, because if we are going to, if you are doing for if you are doing for acid, so this Kc is basically Ka. Kc is equilibrium constant, Ka is acid dissociation constant. Are you getting my point? So can I replace this with Ka? Ka is dissociation constant for acid. Dissociation constant for acid. It's not the ending. Just concentrate here. Dissociation constant of for acid. Now see, can I write it? Ka will be equal to C alpha square upon 1 minus alpha. Can I replace it Kc with Ka? Since
Yes.
the dissociation is very, very less, 5%, maximum 5%, that means alpha is very, very less than 1. So I'm going to neglect alpha. So Ka will be equal to C alpha square. Answer me.
Yes.
Now, what is the value of alpha? What is the value of alpha? So can I write it? Ka is equal to C alpha square. And in the same way, I can find the value of alpha square, that is Ka upon C, and alpha will be equal to Ka upon C. Here you can see C is basically concentration. C is concentration, and you know that concentration has a formula, number of moles of solute upon volume of solution in liter. Are you getting my point?
Yes.
Now, if the number of moles is 1, if n is equal to 1, n represents number of moles. You have to write all this: C for concentration, n for number of moles, V for volume. Because after some time, if you open your copy and then see, then you won't be able to get what is n and what is V. Basically, if n is equal to 1, C will have a value 1 upon V. 1 upon V. I just wrote it wrong. 1 by n. 1 upon V. It will be yes or no?
Yes.
So I'm going to put this value of C here, and alpha is equal to, it will be Ka into V. Can I write it? Because
Yes.
at the place of C, at the place of C, if you are going to put it 1 by V, 1 upon V, it will be in denominator after solving it.
Yes.
After solving it, it will be in denominator. So basically, according to Postwar dilution law, you can see alpha is inversely proportional to concentration. Yes or no?
Yes.
And alpha is directly proportional to volume. So according to Postwar dilution law, for a weak electrolyte, dissociation is inversely proportional to concentration. If the solution is concentrated, a weak electrolyte which is concentrated, the dissociation will be very less, and if it is diluted, the dissociation will be large. Is that clear?
Yes.
Okay, I'm going to slide it up. Please let me know if you're done with this. Okay, wait a minute.
Alpha represents dissociation.
Yes, dissociation.
What is X?
X is basically, this is just suppose this is dissociated moles. Degree of dissociation, basically alpha is degree of dissociation. Just write it, degree of dissociation. X is just, if it is dissociating, that means C is dissociated into X. That means C minus X will be left, and X will be formed.
Can you scroll down?
Yes. Please let me know when you are done with this. In the next class, we will complete this chapter. Then we will start thermodynamics.
Done.
Very good. Now, BOH. We are going to do it for BOH, not all. It will be similar. You know that this will be B plus and this will be OH minus. In the same way, if it has a concentration C 0 0, it will be C minus X, then X, and you know that this will be C alpha. In the same way, it will be C alpha, it will be C alpha. And for KC, you know that this will be B plus into OH minus upon BOH. Okay, are you getting my point?
Yes.
So can I write C alpha, C alpha? It will be C alpha square, C minus C alpha, 1 minus alpha. So the process will be same and the result will be same. This Kc will be replaced by Kb because it is base, and it will be left with C upon 1 minus alpha, and alpha will be neglected. So in the same way, alpha will be equal to Ka upon C, and in the same way, if C is equal to 1 by V, if C is equal to n by V, that is 1 by V, we are going to take n as 1. So Kb alpha is equal to, Kb into V. This is wrong, not Ka, because here it is base, so it will be Kb. Are you getting my point?
Yes.
So just write it, then we will Postwar dilution.
Done.
Very good. So going to write a statement about this. Write with me. According to this law, DOD, that means alpha, degree of dissociation of weak electrolyte is inversely proportional. Their square root of dilutes. Is it clear?
Yes.
Very good.
Done.
Are you done with this?
Yes.
Very good. I'm going to slide it down and write a point with me. What is the answer of this?
A.
What you just said?
A.
A is wrong answer since alpha is equal to Ka upon C and alpha is equal to Ka into V. You can see the more concentration, alpha will be lesser. Which of the following compound will have highest percent of dissociation? The value of alpha is maximum in D because it will be less concentrated.
Yes.
Okay. Write with me note. Write a note with me. That is basically the value of Kw, dissociation constant of water, at 25 degrees centigrade is constant at 25 degrees centigrade, and which is equal to, we already know about it from pH scale, 10 raised to the power minus 14. But when temperature increases, the value of Kw also increases. The value of Kw also increases due to increase in number of H plus and OH minus. Because if you are going to increase the temperature, H2O will have more H plus and OH minus. Because of temperature, it will move faster, far away from each other, and it will be dissociated into H plus and OH minus. And if the concentration of H plus OH minus increases, that means the value of Kw also increases. Okay.
Okay.
Okay. So here comes ionic product of water. Ionic product of water that is represented by Kw. Are you done with the above?
Yes.
Now going to talk about ionic product of water, that is Kw. You know that H2O is liquid. It is converting into H plus and OH minus. Also, if we are going to take 2H2O, wait a minute, I just need to change the Akifah.
Yes.
Now see, if you are going to keep it as take it as H3O positive and OH minus, so I'm going to just balance it. Either you can write this reaction or this reaction, both are correct. Okay. So if you are going to write Kc will be basically H plus or OH minus upon H2O. And we can also write Kc into H2O. That will be equal to H plus into OH minus. And again, you know that we call this Kc into H2O as Kw. Kw is equal to basically H plus into OH minus. Okay. And this Kw has a value 10 raised to the power minus 40. And we can also write Kw is also equals to H3O positive into OH minus. Just write it and let me know if you're finished with this.
Done.
Very good. Wait a minute, wait a minute. Now we will have solubility. Just write a topic. Solubility, or we also say solubility product, and denoted is as KSP, or also say solubility product constant. Solubility product constant, KSP. It is applicable for sparingly soluble salt. It is applicable for a sparingly soluble salt. So basically solubility product or solubility product constant is applicable for a sparingly soluble salt. Just write it. Are you done with this?
Yes.
Or you can write salt of, generally salt of D block element. Salt of D block element. Just suppose AB is a salt which is in solid state and it is converting into A plus, that is in aqueous, plus B minus, that is in aqueous. So basically this is undissolved, this is undissolved solute. This is undissolved solute, and this is dissolved solute. Dissolved. So you know that salt which does not dissolve, that means it is in solid state, and when it is dissolved it will be in aqueous form. It will be dissociated into ions. Done?
Yes.
Now first we will talk about types of solution on the basis of solubility. Types of solution on the basis of solubility. The first is basically saturated solution. What is saturated solution? Just taking an example, if you are going to add 25 or 50 gram of sugar in a glass of water, then again you are going to add sugar in water. A time will come when there will be no sugar can be added in that glass of water. That point is called saturated point, and that type of solution is called saturated solution, where there no more solute can be added. Are you getting my point?
Yes.
Okay, so just write it. The solution in which maximum number of or maximum amount of solute dissolved or further solute cannot be dissolved is called saturated solution. Is called saturated solution, where there no more solute can be added. That type of solution is called saturated solution. And in saturated solution, the solubility will be equal to molarity of solution.
Done.
Very good. The second type of solution, that is unsaturated solution. And what is unsaturated solution? Just write with me. The solution where more solute can be added. The solution in which further amount of solute can be dissolved. Can be dissolved. It's called unsaturated solution. And here amount of soluble solute amount of solute is basically less than solubility. Solubility here is greater than amount of solute, where there more solute can be added. That type of solution is called unsaturated solution. And the third one is Akifah.
Yes.
Okay. Supersaturated solution. The solution in which extra amount of solute is precipitated. Extra amount of solute is precipitated when solution is solution comes to rest. That means first it dissolved, and then when solution comes to rest, is some part is precipitate. PPT is formed. Comes to rest, or solution comes at rest. That means here amount of solute is greater than solubility. And you can write it is less stable.
Done.
Very good. Now come to the KSP. And what is KSP? We are going to define with taking an example. We have already taken an example, AB, that is in solid and undissolved. When it will be dissolved, it will be converted into A plus aqueous and B minus aqueous. Okay. Now going to write the value of Kc, expression of Kc, that will be equal to A plus into B minus upon AB. And also I can write Kc into AB, that will be equal to A plus into B minus. And also this Kc into AB, that is solved from D block, that is known as KSP. KSP will be equal to A plus into B minus. So how we are going to define KSP? KSP is the product. We are going to define KSP solubility product. Solubility product or solubility product constant. Solubility product. It is defined as product of concentration of ions raised to the power of their stoichiometric coefficient. in saturated solution at constant temperature. So basically KSP solubility product is defined as product of concentration of ions. Here the coefficient was 1, so the power is also 1. If there will be some coefficient, it will be in power in KSP expression. Is that clear?
Yes.
Are you done with this?
Yes.
Yes.
Yes, done.
Very good. Now always remember, write a note. KSP given gives an idea of solubility, gives an idea of solubility of salt in a given solution. If I'm going to write, just see here, if you are going to AXBY, if it will be dissociated, you know how it will be dissociated. It will be XA raised to the power plus Y and YB raised to the power X minus. And if you are going to write KSP for this will be A, that is cation raised to the power X, and B, that is anion raised to the power, and it will be Y. This is basically KSP. In terms of AB, it was very easy. In terms of this is also easy, not tough. Okay.
Done.
Very good. Relation between solubility and solubility product. Relation between solubility and solubility product. See, AB is in solid state, and if it is dissociated into dissolved ions, that is A plus equals minus B minus equals. Now see, here it has number of moles 1, so it will be solubility, just take it S, and here it is also S, so it will be S. It will be or not. If it has a solubility S, this will have also S, because the coefficient is same. Now we are going to write the expression of KSP. KSP is what? KSP is the product of ions, that is A plus, to the power of its coefficient, that is 1, so we don't need to write, and it will be S into S, and here KSP will be equal to S square. And for this reaction, different relation will be for different reaction between KP and solubility and solubility product. So here it will be S will be equal to KSP under root of KSP. For this reaction, the relation between solubility and solubility product. This solubility, this S represents solubility, and here solubility is defined in terms of mole per liter, and this is KSP is basically solubility product. Solubility product.
Done.
Very good. Now see another example. N A to B in solid state will give 2A plus and B minus 2. Yes or no? How I am dissociating it? Are you getting it?
Yes.
Now see, this will have a solubility 2s because it has 2 mole, and this will have solubility s. Again, KSP will have a formula that will be equal to A plus raised to the power whatever is the its coefficient and s. And this will be B minus 2. This will be B minus 2. Again, A plus, what is the solubility of A plus? That is 2s. So square of 2s, and again s. So what will be 2 to the 4 s cube? That will be equal to KSP. And you can also write s will be equal to that will be s cube will be equal to KSP upon 4, and taking 1 raised to the power 3 both sides power. So it will be 1 by 3. Yes or no?
Yes.
Okay, just write it and let me know if you're done with this. Done?
Done.
Okay, write the relation between KSP and S, solubility and S, for this reaction, AB3. Can you write it?
Yes.
Okay.
S is equal to KSP over 27 raised to the power 1 by 4.
What you just say, KSP is equal to basically 27 S raised to the power 4, right?
Yes.
So S will be equal to KSP 27. Okay, very good. This is it. Now, can you do this for A2B3 type?
Okay.
Yes, it is almost the end of the chapter. We will do. We will have some questions in the next class. Then we will start thermodynamics. Done?
No.
Okay.
KSP over 108
Okay,
raised
okay,
to the
got it.
power.
KSP will be equal to 108 S raised to the power 5, right?
Yes.
Okay, thank you.